10% significance level, you go to the standard charts, the charts that I just showed you that have been developed by the scientists and researchers, these charts. In a second, I'll share it with you. You go to these charts and you find out where the 10% significance level is or where the 10% probability is. So this looks more close to 10%. Now of course 0.1 means 10%. So for a 10% probability or for a 10% chance, the standard Z value, which is computed by scientists based on standard normal curve, is minus 1.28. It is actually, it's divided into two. You read the first two digits from here and the third digit from here, so it's minus 1.28. Now then you come back and compare the Z value that you have calculated with the standard Z value that you determined from the table or from that chart. And if in case of a positive, just a second, let me share this with you. In case of a negative value, if your Z value, if your computed Z value is less than the Z value from the table, then which means your value falls in this critical region, in this red region. See, because this is negative, this is 0 and it's here, so your negative value is falling here. So the computed Z is less than the standard Z. In that case, you reject the null hypothesis because it's falling in this critical region. In case of the positive, it's just the mirror image. It's just the opposite. Positive is over here. So in case of a positive values, if your Z value is greater than the standard Z value, then again you reject the null hypothesis because it's falling in this critical region. Is it clear now? Naveed? Okay. Good. So let's take a 5 minutes break, then we'll come back and we'll discuss the two-tailed test. Okay? Okay, so is everybody back, or are you waiting for someone? Okay, sure, no problem. Take your time. So are we back now? Should we begin? Okay. So, so far we discussed the one-tailed test, one-tailed Z test. Our next example or our next discussion is about two-tailed T test. Now, what was one-tailed? When we said that we claimed either a definitive increase or a definitive decrease of certain value, then we call it as a one-tailed T test. However, in two-tailed, a statistical test used in inference in which a given statistical hypothesis, let's say H naught, will be rejected when the value is either sufficiently small or sufficiently large, which means we do not define a definitive increase or decrease, but we say that it could be either between this and this. So it could be, let's say that we say mean value is not 5, so which means the mean value could be less than 5 or mean value could be greater than 5. We do not define a definitive increase or decrease. In that case, we conduct a two-tailed test, and you see here that we have two tails here. Now, how do we usually write it? We say that this Z value is less than the Z value we computed, which is less than this standard Z value. So if I write it, I will say, let me bring this down and let me write here. So how do I usually read it? When I write it, I say standard Z value or minus Z value is less than the value that I computed, if I call it X, is less than this positive Z value. So when we'll do the next example, you'll understand what the two-tailed test is about. It's just that we don't define a definitive increase or decrease in our hypothesis or in the value that we think, but we say that the mean that our hypothesis is that anything could be less than this mean or could be greater than this mean. It could vary between less and more. So this is an example that will explain to you what the two-tailed test is about. A telephone mail order company wants to determine if the average time between telephone orders has changed from 3.8 minutes. Now, this was there is a telephone company that places order based on telephone, and the average distance between two orders was 3.8 minutes few years ago. Then they felt then that the average time has changed from 3.8 minutes. Now here, in this case, we are not saying that it has increased or decreased. It has just changed. So it could be an increase in mean time, 4.5 minutes, or it could be decrease in mean time, 3 minutes. So they just want to see the difference. They just want to see the change. It could be an increase, it could be a decrease. There is no definitive increase or decrease in that. So to prove this claim or to see whether this is true or not, the company collects a sample of 100 calls and they find out the mean time between the calls. And the mean time of these 100 calls is 4 minutes, or the distance between the mean distance between the calls is 4 minutes, and the standard deviation is 0.5 based on this 100 calls or the 100 orders that were placed. And the significance level of this hypothesis test is selected as 2%. So now 2% means, in terms of a two-tailed, 2% means that it's